Biostatistics hacks. How to choose the right statistical test for your study. Choosing the correct statistical test is crucial for valid study results. In this video, we'll break down how to select the right test based on your data and study design. Step 1. Understand your data type. Categorical versus continuous data. Categorical data. Nominal, like gender, or ordinal, like pain scale. Continuous data. Interval or ratio, like blood pressure, height. Tip. Always start by classifying your variables correctly. Step 2. Define your research question. Comparing groups. Are you comparing means, proportions, or survival rates? Assessing relationships. Do you need to explore correlations or associations between variables? Prediction. Are you interested in modeling outcomes based on predictors? Step 3. Determine the number of groups/variables. One group. Testing a single group's mean or proportion, e.g., one sample t-test. Two groups. Comparing two groups. Use independent t-test, chi-square test. More than two groups. ANOVA or Kruskal-Wallis for continuous data, chi-square for categorical data. Step 4. Choose between parametric and non-parametric tests. Parametric tests assume normal distribution like t-tests ANOVA. Non-parametric tests, no assumption about the distribution, like Mann-Whitney U test, Kruskal-Wallis. Quick tip, use parametric tests if your data is normally distributed. If not, go for non-parametric alternatives. Step 5. Common Statistical Tests Guide, 5 to 8 o'clock. 1. Comparing means. One sample t-test. Two independent samples. Independent t-test, parametric, or Mann-Whitney U, non-parametric. More than two groups, ANOVA, parametric, or Kruskal-Wallis, non-parametric. 2. Comparing proportions. Two proportions, chi-square test or Fisher's exact test. More than two proportions, chi-square test. 3. Assessing relationships. Correlation, Pearson's, parametric, or Spearman's, non-parametric. Regression, linear regression, continuous outcome, or logistic regression, binary outcome. Step 6. Consider study design and data structure. Paired versus independent samples. Paired data, for example, before and after in the same group, requires tests like paired t-tests. Repeated measures. Consider repeated measures ANOVA or mixed models for data collected over time. Survival data. Use Kaplan-Meier curves and Cox regression for time-to-event analysis. Step 7. Quick reference chart. One variable. Categorical, chi-square or binomial test. Continuous. One sample t-test or Wilcoxon sign rank test. Two variables. Categorical, chi-square or Fisher's exact. Continuous. Independent t-test or Mann-Whitney U. Continuous plus categorical. ANOVA or Kruskal-Wallis. Correlation/association. Continuous plus continuous. Pearson's or Spearman's. Binary outcome. Logistic regression. Always check the assumptions of your chosen test. Use software like R, SPSS, or Stata to guide your choice and perform tests. Seek guidance if unsure. Choosing the right test ensures your study's integrity. If this quick guide helped you, please like, subscribe, and check out our other biostatistics videos. Stay tuned.